Okay, we are on to 10.6 combinations. A combination of items occurs when the items that are selected are from the same group. No item is used more than once. In order, the items make no difference. So order makes no difference. This is the number one distinction between a combination and a permutation, is that in a permutation, order matters, and in combinations, order doesn't. Okay, so for our first example, for each of the following problems, explain if the problem is one involving a permutation or a combination. So how many ways can you select 6 free DVDs from a list of 200 DVDs? So this makes no sense to you probably, but back in the day when DVD players were new, you would get when you bought one, you'd get a little order sheet, and you could get 6 of any of the DVDs that were on the list. They were always terrible movies, but that's what a lot of people did. You'd select these free. So this is what this problem is looking at. So does it matter what the 6 DVDs are? Well, you might have preferences. This is just asking how can you select 6. There's no first place. So this one is a combination. Order does not matter. So combination. So in a race in which there are 50 runners and no ties, how many ways can you select the first 3 finishers? Well, here order matters. The first race, the first place person, and the 50th place person, you're not going to give the 50th place person a first place winner. So order matters, so therefore it is a permutation. So perm. Okay, so let's go on to our next slide. Okay, on your guys' page, you have that same try it yourself. So 6 students are running for student government president and vice president. Is this going to be a combination or permutation? Well, you say this would be a permutation because order matters. You want the president and vice president. Those are first and second place, essentially. Okay, so combination of n things taken r times. So the number of possible combinations if r items are taken from n items. So n choose r is how we read this. So n factorial over n minus r factorial times r factorial. So this looks quite a bit like the factorial and the n above a thing we had previously. It is essentially the same formula. Okay, so from a group of 10 physicians, how many ways can 4 people be selected to attend a conference on acupuncture? So our total is n, and out of those n, we are choosing r, and we see that that is 4. So we have 10, choose 4, 10 factorial over 10 minus 4 factorial, 4 factorial. Okay? So this gives me 10 factorial over 6 factorial times 4 factorial. You know I'm going to expand on the 10, so 10 times 9 times 8 times 7 times 6 factorial. The 6 factorials cancel. The 4 expands on it 4 times 3 times 2 times 1, but that doesn't need to be shown. We have 2 times 4 is 8, and 3 goes into 9 3 times. We can multiply all these out, and you see that it is 210 ways. So if you have 10 physicians in your group, and your company can only afford to send, or your hospital can only afford to send 4, you have 210 ways to choose. Okay, and the last try it yourself. You have a 3-person committee. 3-person committee that needs to study ways of improving public transportation. How many committees could be formed from 8 people? So total 8. So your city hall decided to have a group look at this, and they have 8 people on it. They only want to have a subcommittee that has 3. So we have n being 8 people we're choosing. R is 3. So you have 8 choose 3. And then that gives us 8 factorial over 8 minus 3 factorial, 3 factorial, 8 factorial over 5 factorial times 3 factorial. You know I'm going to expand on the top. So that gives me 8 times 7 times 6 times 5 factorial. 5 factorials cancel. 3 factorial is 3 times 2. That's 6. Cancels up here. So we're just left with 7 times 8. So it's 49, 56. 56 ways to form that subcommittee. Okay, guys, so try your combination problems. Hopefully, if you have questions, you're asking. Miss you. Be safe.